for our final sort of video here is maybe just take a look at a few past papers. I don't know if I'll give you answers to things, or whether I'll just pick up on questions and look. So if you see this, do this, and if you see this, we'll see how this video goes. It might be a bit random. You've had 2 videos already that take you through that last minute revision for paper 1s. You've had that. So this is just paper 1's now random, starting with the one you did as a mock. Okay. So if we have a look at question 1, I'll make notes if I need to. It's Venn diagrams, but I can see X's, okay? Now, what I'd say here is there could be any question where you see this, X's, okay? So the chances are that when you see a question on angles or perimeter or Venn diagrams or whatever it is, but you've got things like this, right? There's a good chance you might have to form an equation. This plus this plus this plus this equals something. So in this case, without even looking, I'm kind of going, all right, well, I know there's 100 pupils, but rather than a normal Venn diagram question, this probably involves me adding all these. So I would write 2x minus 6 plus 13, which is outside, plus the middle, plus that. And I know that there are 100 pupils in this school. I can collect terms, so I get 6x. What do I get? Plus 7 plus 10, something like that, equals 100, right? So 6x equals 90 and so on. So x equals 15. Once I then know what x is, part B might go, okay, so how many people chose track, right? Well, this is 2 lots of 15, take away 6, which is 24. This is 15, add 3, which is 18, and this is 3 lots of 15, so it's 45 people there, and I can answer any question they want, okay? Right, we move on, okay? Yeah, we know what this is as well. We're good to go, right? Let's just check in on a -3 again, right? That if we were substituting in the -3, I think we'd be fine with the 1, that we just put it in there instead of x. Make sure that we've got, and we write it like that, right? So we're substituting in instead of x that number. Remember that -3 squared is 9. -2 squared is 4. The answer to these minus squareds are always positive because a minus times a minus is a plus. So this becomes 2 times 9, take away 6, which is 18, take away 6, which is 12. Yeah, we then draw it. Right, we plot it, and then we're asked to draw the line. So we're going to end up with something like this when we draw it. Okay, then we're asked to draw the line y equals 1, which we'll do. Right, we're going to draw and look for where the graphs intercept. Okay, we've done loads of that. And we can draw that on there. Any problems, you just put in the comments and let me know, okay? My screen has gone weird. Right, okay. What I want to mention here, little things again, okay, is you know how to share in a ratio, right? But in this case, we're told the larger share is, right? So 3 to 5, but the larger share is £44. So, right? So we're not, this is not add, this is not Adam, add, divide, and multiply. You are given one of the answers, so we need to work at the other answer. However, what some people did is realize, hang on a minute, once I've got this, these are in pounds at the moment, so this will be in pounds, but the answer needs to be in kilograms, right? So a few conversions for you, just to, again, it's hard to, you're not going to remember everything, you've just got to put as much into your brain as you can and see what sticks. So the conversions that we might need is this. 1 kilogram is 2.2 pounds. Okay, that's the one we'd use here. So we'd be working backwards into kilograms to give our answer in kilograms. Okay. Alternatively, 1 litre is 1.75 pints. That's less likely, I'd say, than the top one. But another one that's really, really common is that 1 mile is 1.6 kilometers. They are your 3 conversions. And if you're changing this way, you're dividing by 2.2, 1.75, 1.6. But if you're changing that way, you're times in by that number, okay? So what a few people did when you did this in the mock is they changed this into kilograms before they started. And they went, okay, what's 44 divided by 2.2, right? Not the easiest, okay? However, you could times them both by 10, okay? And then do that, and you'll get the same answer. 22 doesn't go into 4, goes into 44 twice, and goes into 0, 0 times. So that is 20 kilograms. Okay. 5 goes into 24 times. So if we times that by 4, we get that this is 12 kilograms. All right. An awareness of those might be just in case. Hopefully nothing in conversion in there, but just in case those three in your brain might be useful to you. Okay. Right. Mean, all we're going to say about mean, right, is that the mean times the number of numbers will tell you what the numbers need to add up to. Okay. In this case, there are the mean is 20 and there are 5 whole numbers. So these numbers will add up to 100, right? We're then told that 3 of the numbers have a mean of 22, which means those 3 numbers add up to 66. Therefore, if I take those away, the other 2 numbers must add up to 34, right? So the other 2 numbers must add up to 34, and these 2 numbers have a difference of 6. We'll just try it, right? 11, they have a difference of 6, but they only add up to 28. Let's keep going up. They have a difference of 6, but they add up to 30. And you'll get there in the end. I'm jumping a bit here. 14 add 20. Okay. They add up to 34. They are the other 2 numbers then, 14 and 20. I don't want to go into this much detail on all these, right? Equation of a straight line, maybe. Okay, look, this is things to spot. So first of all, that's C. That's where it cuts the y-axis. Then for every 1 step across, we're not going upwards, we're going downwards. How far? We're going down 2 and another 2. That's gone down 4. So the equation of this line, minus 4x plus 2. Remembering, that's the gradient, and then that's the y-intercept there. Hopefully that is what they ask. I'm just trying to do this, write down the gradient first of all, and then write down the equation of the line, and write down another that's parallel. Well, as long as the gradient stays the same, they're parallel, and just stick another number in there. Whatever, any other number will do, okay? Must be a nice question, wouldn't it? How many tiles would you expect in pattern N? Patterns, another word for sequences. Nth term. Pattern N, nth term, just another way of writing it. Well, I can't do nth term with pictures. I've got to change these into numbers. Okay, so there's 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 16, 17, 18, 19. Oh, okay. Awkward one. Do want to pick up on this, right? If this was going 4, 7, 10, 13, ... then the pattern would be 3n plus 1, right? If it's going up by differing amounts like ours, 4, 7, 12, 19, etc., then the chances are it's something to do with n squared, right? And that's why they've drawn it like this, right? What I've got here is a 4 by 4 square and an extra 1, 2, 3. Here I've got a 3 by 3 square plus 3. Here I've got a 2 by 2 plus 3. And here I've just got a 1 by 1 square in here plus 3. So the nth term here will be n times n, or n squared, plus 3. Okay, so that's just something to be aware of. If they're going up by different amounts, it's something to do with n squared. It could be n squared plus 1, or n squared plus 2, or in this case, n squared plus 3. I'm not going to mention it. You can have a go at it, okay? It's tricky. Right. Simultaneous equations. But they haven't said it because it's wordy. Instead, they've called it an algebraic method. You're not going to get away with just guessing, even if you get it right, right? What's the giveaway? The simultaneous equations. 5 of this plus 7 of this equals this. 2 of these plus 3 of these equal this. As soon as I've read that, I'm like, that's 2 equations, right? 5 of these. It even said Make cherries X, make grapes Y. So you're right, all right, well, 5 of those plus 7 of those equals that. And 2 of those plus 3 of those equals that. Right. Make the Y's the same. Times that by 3, times that by 7. It's going to take a while because the numbers are huge without a calculator, particularly that. Look, 240 add. Don't got that right. And then this one. And you've got to times that by 7 as well. So 210 plus 42, 252. And then same signs, subtract, remember, okay? Because these are both pluses, S, leaving you 1x, or just x. They disappear, equals 12. Substitute it back in, etc., etc. And because it's a wordy one, it allows it to go, okay, once you know what x is and you know what y is, can you now use your answers to tell me what half a kilogram of cherries and 6 kilograms of grapes would cost? So half of the value of x plus 6 times the value of y. But the 5 out of the 6 marks here are for getting these simultaneous equations set up and good to go. I don't want you making mistakes here, people, right? This. All I saw, I haven't even seen the rest of the question. All I saw is that. Oh, okay. This is upper and lower bounds. Okay. It's worth saying, so to the nearest 1 centimeter, we'll add half a centimeter on to get the upper bound, and we'll take half a centimeter off to get the lower bound. Calculate, too many of you went 4 times 15, 60 in the mark. It's not that easy. It's never going to be that easy. Question 8 of a higher paper, is it? So the greatest possible perimeter is 4 times 15.5, which is 62. That's the greatest, which is what they asked for. If they'd asked for the least, it would have been 4 times the lower bound. You've got to pick out those words. Correct to the nearest, rounded to the nearest, to the near, anything like that. You go, this is upper and lower bounds, right? I need to either use my upper bound or my lower bound in my calculations. I'm not going to say anything about factorize. You can write all other than to say double bracket, 2 numbers that times to make the end, that add. Do you know what's awkward here? The minus 11, because that's 8 times 3. To get minus 11, you'd actually need minus 8. Both to be negative to give you the middle number. But okay, that's easy enough. Circle theorems, hurrah! Okay. So, first thing, love this one as well, right? Can we see an arrowhead? No. Can we see any tangents? No. So get rid of those. And then into things like, can I see a bow tie? Yes. There's my bow tie. It's hidden, but there it is, right? Bit of a bow tie. So what can you tell me about x? Well, x equals 79. If they want a reason, the angles on the circumference, you can even go bottom, or angles on the bottom circumference are equal. Don't write angles at the bottom of the bow tie or are equal and angles at the top of the bow tie. Write angles on the circumference, okay? So that's 79. Now, can I then see a cyclic quadrilateral? Yes, I can. Can I change my color? Yes, I can. Right? A to E to C and to B, all 4 points are on the... There we go. That's a 4-sided shape within there. All right, in that case, opposite angles in the cyclic quadrilateral add up to 180. Okay, so if that's 79, y equals 180 take away 79, which is 101. And my reason is opposite angles in cyclic quadrilateral add up to 180 degrees. Beautiful. Excuse my writing. This is very much a rushed, okay? And we've stated the circle theorem and given our answers. Great. Great. Easy enough. Yeah. How long have I got? Last few seconds on this one. Let me zoom. And then we'll do a little bit more. Okay. I can only record these in 15 minutes. That's why I'm doing that. So my last 20 seconds is going to say top times bottom plus 1 minus top times bottom divided by bottom times bottom, and the only thing you have to do is jump there, guys, because I'm doing these in little 15-minute videos, and I'll then merge them together. So apologies if there was. So that's where we were there. I might look. I did say I wouldn't give answers, but I think it's worth mentioning. Okay, minus 8x squared because it's a minus times a plus, and then plus 10x because the last times is a plus times a plus. Simplify that, you get 10x squared, 18, take away 8, and then 3 plus 10 is 13x. However, what I didn't do there is the bottom. Weirdly, the bottom you do not in these examples need to simplify, so that would be your final answer. That is totally fine. What I would say is this, okay, if, and I'm going different color because this is an if, okay, I would hate this to happen, but it is doable. If this wasn't an express, if this was a solve, so they put something like equals 7 on the end, so there was an equals 7 on the end, what you'd then have to do is take the bottom here up here as a times, right? And if it was this question, you would have to expand this. So you'd end up with 24x squared minus 26x, if you take your time and do this, maybe stop the video and check it, right? Minus 5, right? You'd have to times all those by 7. It wouldn't be these bigger numbers if this was a question, okay? And potentially bring these, don't worry if this doesn't make sense because I'm talking probably the hardest question ever here, bring these over there as well. So we end up with 0 equals, and we're going to get a quadratic here, an amount of x squareds, an amount of x's, plus a number at the end. And then you'd have to go on and factorize, double bracket, factorize, in order to find x. You'll end up with two answers, x equals this or x equals this, right? Don't worry if that doesn't make sense. Be able to just be good with the bit that was there, okay? Congruence looks like. Okay. Anytime I know two angles, I'm going to work out the third in a congruence question because it might allow me to do like an ASA or an SAS, etc. So if I work that out, that becomes 42. And if I work that one out, that becomes 63. So these are a case of AAA, right? Three angles the same. Okay. SSS means congruent. SAS, congruent. ASA, congruent. AAA, similar, possibly congruent. So AAA is not a definite congruent triangles. So the answer to that would be could be congruent. Reason, 3 equal angles means they're similar, but they could be congruent. They could be the same size, but it could be that one they're just similar and one is a bigger version of the other. Okay, so if I was drawing these now, hopefully now we're going through papers going, yep, okay, recognize, know what I'm doing, okay? The first one, y equals 1. I'm going to just, okay, y equals 1, that's okay. Make sure we go the right direction and we don't draw the line x equals 1, y equals 1. It goes the way you wouldn't expect it to go, doesn't it? The x lines go up and the y lines go across, which is weird, right? For the other two, I'm going to draw little tables. So let's do this one. I'm going to go, okay, pick some x values, work out the y values, right? Now the x's are going up in ones this time. Look here, 0, 1, 2, 3, 4. So I'm just going to pick a few of those. 0, 1, and 2, maybe. All right. Okay. Y is equal to x plus 3, 0 plus 3, 1 plus 3, 2 plus 3. And I can draw that on here. 0, 3, 1, 4, and unfortunately 2 actually goes up to 5, which is slightly off there, but you've got enough information, you've got enough kind of there to get that line drawn, and you can keep that going with a nice ruler like that, okay? The other one is also not a line I can draw straight away, and again I'm going to need a little table. 0, 1, 2, okay? Now, there's two ways to go about this, right? I tend to rearrange it so that the x goes over and we do it like that. But you could just do x and y need to add up to 4. So what do you need to add to 0 to get 4? 4. 0 plus 4 make 4. 1 plus 3. 2 plus 2. Or you can do it this way and go 4 take away nothing, 4 take away 1, 4 take away 2 and get your answers there. But either way, it goes 4, 3, 2 as we're going along. So it goes 4, 3, 2. And again, we connect them up as best we can. And hopefully, if we use a different color, all right, nice if you've got a different color because you can do that then. And you can see the triangle that you need to color in. Hate them. Do your best, right? What's it about? Surface area, volume. Right, cone, spheres. It's got to be the front of the book. Don't even know it myself. I believe that when we look in the front of the book, that the curved surface area of the cone is pi r/l, where that's r and that's l. So this curved surface area of this is pi times the radius times the length. Looks weird, doesn't it? All right. Oh, look at that in bold, total, because that is just the curved bit. We also, and I've mentioned this in my last video, I think my yesterday video, we said, okay, but actually there's a circle at the bottom of here, which will be pi r squared, right? The total surface area is 144 pi. In other words, that area plus that area equals that. This is the kind of things we're doing with cones and spheres. It's just plopping or plunking or whatever the word is, numbers in, and just kind of trying to work them out. Now, this I could have simplified. I've got here, right? I like the number first, I think, and then the pi, and then I got r times r in there, and then here equals 144, right? But the reason they've left the answer in pi is every single term has got pi in. So actually, at that point, any time we're working with pi, as long as pi is in everything, we can get rid of pi, right? I'm not saying, but if we can get that far, we're going to get 2 marks easy, right? The last mark here, you're going to go, what, right? So what we end up with when we get rid of pi is 5 over 4r squared plus r squared equals 144, right? Yeah. I think a lot of you might do this as decimals because you might find it easier. So it's almost like, right, 1.25 plus 1. I'm going to just do it as decimals for a minute. Not that I think this, because, oh my word. Because you now have to divide that. Divided by 2.25 and then square root it. I'm not going into it. Right, I'm not going into those. Some of you might be able to do it, but I just think I'm going to spend a whole video doing that when there's no need. Right. Again, we should be looking here going, all right, roots, flower power, and a minus means flip. So cube root, 2. Power 1, okay, nothing to do there. Power 1, still 2. Minus means flip, 1 over 2. Right, here, square root of 4, 2. Power 5, 2 to the power 5 is 32. 2 times 2 times 2 times 2, 5 times. Right? Little 1 markers. Don't care about the times 330 bit. I'm only looking at that for a minute. I'm going, that's 215, take away 2 over 990. That's 213 over 990. Yes, I then need to times that by 330. What a lot of you spotted is you can simplify here and go, actually, 330 goes into that 3 times. So you end up simplifying that to 213 divided by 3, right? Whatever that is. 71, something like that. Yeah. Remember, 2x, 2x. You might get a part A here, which is a show. Yeah. And then this could be the part B, the solve bit. Always make sure that if you've got a show then a solve, that you do the solve bit in part B. The show is the horrible bit. Yeah. So remember this time, though, we're timesing not to make minus 20. We have to times that by 2. So we're trying to make minus 40, or just 40 for now. But what is important is getting that middle, that plus 3. So I'm going with 4 times 10. Nope, I'm not. 5 times 8. And then to get plus 3, and only this one will simplify to x plus 4 And people, again, I want you then equal 0. I want you then to hence solve it. Either x equals this or x equals this. Okay, really wanted to do this. Okay, hopefully I've got lots of time. Video. I have. Let's go back. Okay, I'm doing all right. Let me zoom back in. Okay. Zoom back out. I would love to see the whole question. Okay, guys, I know that in school we've done sine and cos, and what we said is sine starts on the line, goes up to 1, back to 0, down to -1, and there. And because of you guys, I've never done this before, cos starts in the cloud. Sine starts on the line, cos starts in the cloud, comes down to 0, down to -1, back to 0, and back up there. Tan is this. Don't worry about learning to draw it, okay? And because it came up in the summer, fingers crossed, tan's gone. However, it's the same thing. They are giving you an answer. They are telling you that if you go to 23, which is about there, I'm guessing, and you go up and across, that answer there is 0.4245. There is another number that would give you the same answer, which is across here, right? But they are not what we want. We want minus 0.4245. So we, again, it's the same thing applies, right? So that's why I don't want that bothered. And again, people, that's that answer there I want, and that answer there. Now let's go. Now we've drawn all the lines in that we need. Let's split this up into whatever, right? So the first number they gave me was 23. Take that away from 90, I get 67. Oh God, typically 67, right? Then we've got 67, 23. 23, 67, 67, 23. So the two numbers that are going to give me these are 90 plus 67, which is 157. And the other one over here is 270 plus 67, which was 337. Okay, so it's the same thing. It's just with a tan graph. Okay. Two similar solids. Okay, similar shapes, but this is going to be areas and volumes. Remember for this one, in fact, yeah, I will do it. Okay, remember this one, guys. Length, surface area, surface, scale factor, and volumes. You can see I'm rushing this video. If you know this one, but you want this one, you're going to square this one. If you know this one, but you want this one, you're going to cube this one. If you know the area, but you want that one, which is far more likely, you're going to square root. Or if you know this one and you want that one, which is also, again, is quite likely, you're going to cube root. Okay. Two similar solids have surface areas. I am dividing areas. That is the area scale factor. The volume of the smaller one is that. So the one I want is the VSF, but I cannot go direct from there to there. I have to go on a big loop around. So I'm going to actually go, okay, let me go back to what my length scale factor is by square rooting that. Now I'll go to my volume scale factor. Now I'll do this by cubing that, which is 125. So if the smaller solid has a volume of 0.4, then the larger one, I need to times that by my volume scale factor, okay? And if I was doing that, I would do 4 times 125, which is 500. But because there is a number after the decimal point there, I need to drop that decimal point back in. So it's actually 50, not 500. You can see me dropping in and out of questions here. And I think, oh my wordy, how many have I got left? I'm just going to add these because I want to talk about these, and I also want to talk a little bit. So let's pick up these last couple on here, and then we're going to just talk about construction and a little bit about angles, particularly exterior, interior, parallel line angles, stuff like that, right? Which I think can be awkward. So there's two things here, right? I always say, if you get lots of surd things, split it up. So the very, right, it's separated by this plus. The very first thing is 250 divided by 5 cubed, right? Well, we could do that, square root of 5 times square root of 5 times square root of 5, because it's the square root of 125. Okay? You can divide, as long as they're both surds, you can divide them. and 125 goes into 252, but it would stay inside the third. Remember, if there was a number here, and a number here, you can divide the numbers as well. But what you can't do is divide a third by a number or divide a number by a third, right? So that's that bit. Then the other bit is a double bracket, which they also love with thirds with brackets. Well, we'll go 4 times 3 is 12. The square root of 2 times the square root of 2 is 2, plus times a minus, okay? Plus 3, again, like dividing, it's a number times a third. Can't do that, just put them together. Same here, a number times a third. Put them together, okay? Now I can collect the numbers together, which is 10, and I can do the 3 take away 4, which is minus 1 square root of 2, okay? Now I put them all together, so the first bit came to that, plus, which is that, and the second bit was 10. That's quite nice though, because a square root of 2 take away a square root of 2. Well, if I've got something and I take it away, it's gone, leaving me the answer 10, which is then rational. But my encouragement for something like this is to do it bit by bit. That bit, then that bit, okay? Right, and I really wanted to do this, which is great, before we get onto that little bit of construction-y stuff, all right? Okay, this is your hard probability, right? Remember, if there's 3 parts, A, B, and C, okay, A is going to be easy. B will be harder. C, you may need to do the opposite of what it says. So in a part C, if the question is about, if this was a color question, then the question is about red. In part C, everything else becomes not red. If this is a letters question, the letters in the word mathematics, if the question is about the letter M, then everything else becomes not M. In this one, and I haven't even read this one, if the last question is about the number 5, then the other two, don't even think of them as 6 and 7. Again, 6, 7. Think of them as not 5, right? If the question is about a specific letter or number or color, everything else becomes not that color, number. Okay? So here, 3 cards at random. Also remember with times in probabilities. So it's be probability times probability, or in this case, because it's 3 cards, times probability. That's what we're trying to do here. Calculate the probability that the first card is a 7. 1 out of 1, 2, 3, 4, 5, 6. The second card is a 5. If I take the 7, there are still 4 of these left, but only now 5 cards left. And the third card is a 6. 1 out of, and now we're down to only 4 cards left as well. So I said the first part should be easy. 1 times 4 is 4. 4 times 1 is still 4. 6 times 5 is 30. 30 times 4. And with multiply the top and the bottom. Now, there's another 2 marker here. This should be okay. I hated it though. I didn't like it. I remember it now. I didn't like it. Calculate the probability that the product means times, of Matthew's 3 cards is a cube number. The fact it's a 2 marker probably means there's only 1 combination, right? Normally, right? If it was 3 or 4 marks, I'd be looking for lots of combinations. So to be a cube number, the only way to have a cube number here is 5. I'd want a 5 on my first card, a 5 on my second card, and a 5 on my third card. Then the product 5 times 5 times 5 would be 125, which is a cube number. So the probability of getting a 5 initially is 4 out of 6. If I take a 5, that goes down to 3 out of 5. And if I take another 5, that goes down to 2 out of 4, which is 24 over 120. Now, surely this gets harder. Is there a part C? Please. Right. Let me write down what I add again. So it was 5, 5, 5, 5, 6, 7. Calculate the sum is add. Product is times. Sum is add. Calculate the probability that the sum of the numbers on Matthew's 3 cards is 17. People, this is not saying, a specific color or a specific number. We have to just list these, okay? I believe. So we could have 5 with a 5 with a 7. We could have a 5 with a 7 with a 5, which is a different combination. We could have a 7 with a 5 with a 5. Are there any other ways of making 17? I do not believe there are. No. So this is why it's an extra mark, because there's more combinations. Okay. Right. I am going to have to do an extra question here. So 5, basically, you'd work each one out. So this one would be 4 over 6 times 3 over 5 times 1 over 4. Remember, okay, there's 4 out of 6 to begin with, but if we take a 5, it goes down to 3 out of 5. And if we take another 5, the chances then of getting a 7 is 1 out of 4. Repeat, do that for that, do the same for there, do the same for there, and then add all your answers together there. Okay, I have to add something else there. Sorry, guys. I haven't even got spare space here. I want to go to a different. I want to do a different part C for a different question. I want to go red, 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 blue, blue, green, yellow. Right. This time, what is the pick 3 again? Pick 3. Right. What is the probability of at least one red? Let's ask that question. Okay. At least one red. And right. This is a question about red. This is a question about red. Therefore, everything else is not red. Make life easier for us. So when I'm working out combinations, my combinations are red and not red, right? So there are still a lot of combinations though. We could have at least one red would be red, red, not red, 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 not red. And you can see there's still quite a lot. So the other thing that could come up in a part C, and it is the last question in the paper, so you are allowed to not do this and get this wrong, right? But is to think of the opposite. What is the opposite of getting one red or more? Well, to get one red or more, I could have one red or 2 reds or 3 reds. The only thing not included there is no reds. So not a red, followed by not a red, followed by not a red. So I'm going to do the probability of that. How many are not red to begin with? 4 out of 1, 2, 3, 4, 5, 6, 7. Times, if I take one that's not red, I'm now down to 3 out of 6. If I take another one that's not red, I'm now down to 2 out of 5. 24 out of 42 times 5, 210 maybe. Okay, so the chances of not getting a red, not red, not red, not red, is 24 out of 210. Therefore, the probability of getting at least one red, I'm going to take that away from 210, which gives me 186 out of 210. I don't particularly mind if that doesn't make sense, right? But I would say to you, there's a good chance that you might have to, for part C, group things into not something and also look at doing the opposite. If I said, what's the chances of getting at least one M? You look at the probability of getting no M's. If I say, what's the probability of getting at least one blue? You look at the probability of getting no blues and you group everything as not.